was involved with drilling a well in southwestern Oklahoma in 2004. Unfortunately, we didn't find any oil or gas, but we did find a new kind of black gold, namely Nano Magnetite. The problem was, however, that the Nano Magnetite was mixed with the salt water, and we had to come up with a way of separating the Nano Magnetite particles from the salt water. So what I've got here is a diagram of a process for separating the Nano Magnetite from the salt water or the brine. What we do is we retrieve the brine and the Nano Magnetite from the well, and we put it in a barrel, and we pump it out of this barrel, and we run it through a clear plastic pipe. However, the plastic pipe is sitting on top of a group of ceramic magnets, on top of which lies a magnetic flux focusing trough, so that when the mixture of Nano Magnetite and brine pass through this pipe, the magnetic particles are attracted to the bottom of the clear plastic pipe, and the brine is disposed of back into the barrel where we have the original well water. We let this circulate. It's a circulating process, so that after a while all the Nano Magnetite is deposited on the bottom of the clear plastic pipe, and that the brine simply circulates through the system. The magnets are about 10 feet long, and they're inclined at about they're upward inclined at 1 inch, so that the downward gradient here is less than 1 degree. So it's just a gentle movement of water down dip, and these magnets pull the magnetic particles of Nano Magnetite out of the brine, and we collect them after they've been attracted. Now, what we're going to do next is we're going to go out to the shed where we built a prototype of this process, and we're going to demonstrate how this process works. Okay, this is our magnetic separation equipment that I mentioned earlier, and the purpose behind all this is to separate the Nano Magnetite from the salt water as we produce the salt water from the well. What we have here is a series of ceramic magnets, about 10 feet of ceramic magnets. Here's one of the magnets. They're commercially made. They're very, very strong magnets, and we utilize the edge of the magnet where the field strength is greatest. Sitting on top of these ceramic magnets is a piece of galvanized steel. What this does, it focuses the magnetic field onto the bottom of this piece of plastic pipe. Now, our well water contains the magnetite, and salt water that contains the magnetite is in this bucket right here. And what we're going to do, we're going to pump the salt water magnetite using that submersible pump. And it's going to go in the top of the tube here and drain down the slope. And as it's draining down, the magnetic field, because the magnetite is ferromagnetic, it will attract the magnetite and pull it out of solution. Let me go ahead and place this submersible pump in our bucket of salt water, and I'll turn it on. I'll plug it in. Okay, here comes the solution coming down the pipe. You can see it coming down here. Pretty soon it'll be running out here. It's running back out in here. Our salt water. Let me increase the flow rate. And you can begin to see the magnetite collecting on the bottom of the tube here. That black material on the bottom of the tube is the magnetite. Let me place this card in here. And you begin to see as the magnetite collecting on the bottom of the plastic tube, coming out of the tube. Eventually, as we continue to recycle it, it won't take long it'll be clear. At that time, after all the magnetite is in the bottom of the plastic tube, we can then remove the plastic tube and harvest the magnetite out of the tube. This is the prototype design, and it can be upscaled to accommodate much larger volumes of water. Yeah, you can see the color of the magnetite, the water, the nano magnetite in the salt water makes it black, and after it passes through the magnetic processing, the color is a lot less black, and eventually, if we recycle this long enough, that black will go away, and the fluid will be clear.